So today our next topic we are having, that is the weightlessness. What does it mean? It means you feel your weight, that your weight is zero when there is no gravity. Okay, you feel that your weight is zero. You will like feel that you will fly. Okay, so in that you can say if you will move outside of the earth, so then there will be no gravity. You will fly. You will feel that you are having no weight. Okay, so that is called the weightlessness. Okay, so how the weight is basically zero in the presence of gravity, that we will be watching this in this video. Okay, consider that is the lift. Okay, that is the lift and there is the string. Okay, and here the one mass is there. Okay, if we talk about the weight of this mass will be downward, and if we talk about the tension or the normal reaction will be upward. We are calling that as a tension or the normal reaction. So the spring balance basically this is a spring balance. Okay, uh, so this spring balance basically tell the weight and the equal tension will be there. Okay, if we talk about the weight and mass, what is the difference between weight and mass? Let me tell you guys about that. If you talk about weight is basically not constant. They are not constant, like they will be. If you will move outside of the earth, you will feel that your weight is like zero. If you will be there in the earth, you will say that your weight is basically something like that. So weight is basically not constant. If you talk about mass is always constant. If you are outside of the earth, if you are inside the earth or everything, so mass is basically never be zero. Weight can be zero, but mass cannot be zero. They are constant. Okay, and if you talk about the mass, we will measure this by the physical balance. Okay, if we talk about the unit of the weight, that is Newton. If we talk about the unit of the mass, that is kg. Okay, and if you talk about this, so this is independent and this is dependent, as you guys all know. Okay, so weight can be zero, weight can be positive, negative, but if you talk about mass will be never zero. Mass will be never zero. So with that we are having the four cases. Okay, weight, as you guys all know, depend upon all the gravitation pull to the center. If there is gravity to your body, so this means you will feel your weight. So we are having the four cases. Case 1, case 2, and case 3, and this is case 4. Okay, so what is case 1? Case 1, which means that your mass is basically at this means this is the, you can say that this is the left. Okay, and one body is there, and this is basically having no tension. Okay, and but their body is having the weight, which means that if there is acceleration is equal to the zero, if the acceleration is basically zero, or the net force is basically zero, or the body in the uniform, you can say that in the uniform motion, so the tension will be equal to the weight. What is tension? Tension is the apparent weight. We are calling you can call that as a tension, you can call as the normal weight. So this upward weight, that which is the normal reaction or tension, these are basically apparent weight. Apparent weight is not real, and this one weight is the real weight. The real weight. Okay, if you are in the left. Okay, for example, I'll be telling you that example in this case. Okay, so the spring balance will reveal the actual weight of the body, as you guys all know. And if you talk about the case 2, for example, the lift is basically moving upward. When the body is there, lift is basically moving upward, which means the tension is more and weight is less. So we can say the tension minus weight. And if we talk about tension, so you guys all know weight is basically having the upward force too. So we can say that W plus F. As you guys all know, if we talk about W, we are having that is the mg formula, and if we talk about F, we are having the ma. So we can m will be common. Okay, and g plus a will be there, which means that apparent weight formula, we are having the one apparent weight formula, which is the mg plus a. This is apparent weight formula. So this is when the acceleration is basically not equal to the zero and the body is moving upward, you will feel the apparent weight more. You will feel that your weight is basically more, just because of what? Because you are moving upward, the tension is more. Okay, so and weight is basically will be less, so you will feel that your apparent weight is more. Apparent weight is basically not real weight. The weight that you feel, that is the apparent weight. If we talk about the third case, in third case we are having that the acceleration is also equal to not zero and the body is basically moving downward with the acceleration. Okay, in this the tension will be less and the weight will be more. You will feel that your apparent weight is less. Okay, and your, like, you can say that your actual weight is more. Your actual weight is more because if you're like if the lift is moving downward, you will feel your body is heavier, just because there is no tension on your body. Like upward force is no upward force, but you are having the downward force. Okay, so we can write here that F is equal to W is basically more and tension is less. So we can write it T minus F. Okay, and we will be having that T is equal to mg. As you guys all know, we have written upward side to T is equal to mg minus A. Okay, so if we talk about this one, okay, so this is the, in this the apparent weight will be, you can say, less and actual weight will be more. Okay, so if we talk about the, that we are having the case 4 in which the lift is like not moving, like lift is basically free falling. Lift is free falling. Okay, lift is basically free falling, and it means there is no tension. There is no tension, and there is basically, you can say that the apparent weight will be zero. Tension is zero or apparent weight is zero, which means your body weight will be zero. You will feel that your body is having, if the lift is basically moving downward very fastly, and you will feel that you are having no weight, which means your tension or upward apparent weight is zero, which means you will feel that your weight is weightlessness. We are calling that as the weightlessness, in which your body, you will feel your body is having no weight just because of the no tension. So this was a special case of the, this one, the weightlessness. So this was about the weightlessness plus the, you can say that, all the cases. In the next video we will discuss about the weightlessness in the satellite. Okay, apparent weight is basically depend on the state of the body. Okay, like rest, motion, they will be changed. If we talk about the real weight, they will be not change. If the body is in motion or rest, they will not change. But apparent weight will be changed if there the body is in rest, motion, or in any kind of a motion. That weight, apparent weight, will be, can be different, but real weight will be never different. Okay, so this was about the weightlessness plus the cases. In the next video we will move toward the weightlessness in the satellite.